Hi all, and thank you for coming to this session. My name is Amal Nanavati, and today I will be talking about our experiences developing and teaching a mandatory 8th grade Python course. This is joint work with Aileen Owens at South Fayette School District, where the course is still being taught today, and Mark Stehlik at Carnegie Mellon University. Why do we need an 8th grade Python course? As we all know, there are numerous block-based programming curricula for the elementary school level, such as Scratch. There are also numerous text-based programming curricula at the high school level, such as AP Computer Science and Exploring Computer Science. However, there isn't much in terms of a middle school transition between the two. Further, as we are aware, computer science and computational thinking are tools that can be applied to numerous different fields. This creates an opportunity for students in high school to use computer science concepts as part of other courses. For example, to analyze data from a chemistry lab, to create an animation for a history project, or to code up math formulae. However, this requires that students enter high school with a background in computer science. To address both these needs, we developed an introductory Python course for 8th grade students, which our partner school district then made mandatory for all 8th graders. This presentation focuses on that course. We begin by describing the school district that we worked with. We then move on to describing the curricula and why we designed it the way we did. We then talk about the teachers' experiences teaching this course, since this was the first time our school district offered a mandatory text-based programming course. And we finally present results from pre- and post surveys of students' perspectives about computer science. This project was a collaboration between Carnegie Mellon University and South Fayette School District, a suburban school district of around 3,300 students near Pittsburgh, Pennsylvania. South Fayette School District has defined computational thinking as a new literacy for all students and has been working over the last 9 years to embed it into their K-12 curriculum. On the K-8 level, this includes block-based programming in Scratch and App Inventor, VexIQ Robotics, and Squishy Circuits. On the 9th through 12th grade level, they offer multiple elective text-based programming courses. However, one thing South Fayette has noticed is a gap between students' interest and engagement between the block-based portions in elementary and middle school and the text-based portions of their curricula in high school. Addressing this gap was one of the motivations to create this course. The other motivation, as I mentioned before, was to enable students to use computational thinking concepts as part of their other non-computational courses in high school. As one way to achieve their computational thinking goals, South Fayette School District uses incubator courses, which are after-school courses that allow them to test new ideas and leverage external talent. The curriculum that we focus on was initially created and taught by Technology, a Carnegie Mellon student organization, as an incubator course in spring 2017. We then worked with South Fayette School District to improve the course over summer 2017, and it has been taught as a mandatory course at the school district for all 8th graders since fall 2017. There have roughly been 25 students per class and 270 students per year. This presentation focuses on the second year of teaching this course, the 2018 through 2019 year, and we are now into the third year that this mandatory course has been taught at South Fayette School District. The course was 1 trimester long, or 30 classes on a block-based schedule, with roughly 40 minutes per class. It was divided into 3 units, intended to expose students to the range of ways computer code can interact with the world. These units were Command Line, Turtle, and Finch Robotics. Each class period began with some instruction, followed by guided practice, where the teacher wrote code on the board and students followed along on their laptops. Each class ended with students working on coding challenges, typically in pairs. Finally, the entire course was themed around The Martian, a film about an astronaut, Mark Watney, who gets stranded on Mars. At the beginning of the course, students are told that they are Mark Watney's tech team, and it is up to them to help Watney survive. Activities in every unit tie into this theme, and in the final unit, the Finch robot is Watney's Mars rover that students need to navigate around Mars to help him survive. In the first unit, students learn the basics of Python code. They begin with print and strings, where they have to send a help message to NASA. But they must be careful, because there's limited bandwidth on Mars, so they have to send the most information possible with the least characters. They then move on to variables and numbers, where they create a variable for Mark Watney's remaining oxygen supply, and then spring concatenation, where they print how much oxygen is remaining. They then learn user input and have to ask NASA how soon they can send rescuers. They then move on to mathematical operators, where they calculate how long Watney can survive on this level of oxygen. And finally, conditionals, where they print a warning if the oxygen level gets too low. This unit had two larger activities. Mad Libs, which students did after learning input and string concatenation, involved students asking their classmates to fill in the blanks of a story. This is sample student work, where they ask their classmates for two adjectives, a noun, a plural noun, and an adverb, and then use those as blanks to fill in the story about a brave knight. The second activity was Trivia Game, which students did after learning conditionals. In Trivia Game, students ask their classmates questions, check whether their answers are correct or not, and give them a score based on that. That brings us to our second unit, Turtle. Turtle is a built-in module in Python that allows users to create a turtle and then move it around on screen with commands such as forward or turn right. As the turtle moves, it draws a line behind it. Enclosing a series of forward and turn comments in a loop allows students to create interesting geometric designs, as well as simulate the type of commands they would send to a robot. We used the turtle to teach students while and for loops. Students first began by using these loops with the command line to, for example, print Watney's remaining potatoes every day, or print the number of days that Watney has been on Mars. A student favorite activity, which was thought up by particularly inquisitive students, was to use loops to get their programs to crash by looping forever. We then moved on to the main activity of the unit, which was using turtles to draw geometric patterns in the sand of Mars so that a passing satellite could detect signs of life. Challenges in this part ranged from taking code that had been copied multiple times and replacing it with a for loop, to drawing geometric figures such as squares and circles, to drawing very unique geometric patterns that allowed students to be creative. These are two samples of student work from the unit, where they drew these colorful and geometric patterns using loops and the TurtleBot's capabilities. Our third and final unit was the robotics unit. This unit involved students controlling the Finch robot, which is the robot seen here, created by BirdBrain Technologies. Students are told that the Finch robot is Watney's Mars rover. Watney's satellite dish has blown away, and students have to send the Mars rover out to retrieve it. At this point, students have all the programming tools they need to use the Finch. Therefore, this unit focuses on a series of challenges. First, the students must get the Finch to move around. However, if it becomes nighttime while the rover is out, the Finch will need to turn on its headlights. Therefore, students have to use conditionals and the Finch's light sensors to determine whether it's dark outside and then turn on a light.
Oh wait, it might not. No, it works.
Finally, they have to get the robot to systematically search an area in order to find the missing satellite. In addition to the aforementioned coding exercises, we also integrated. Since this was the first time our school district had taught a mandatory text-based programming course, we conducted a semi-structured interview with the teacher. Notably, teaching computer science to all students, as opposed to just those with prior interest, was a novel experience for the teacher as well, and she found that there was a high variance in students' abilities and interests in computer science. She felt that a couple of aspects of the course were especially crucial to accounting for the mandatory nature of this course. First, she found that when students started losing ground in the course, they began giving up, and it was very hard to rekindle their interest. Therefore, the teacher worked hard to ensure that students were not losing ground in the first place. This included relying on study hall, a flexible period at the end of every day where students could go to any class they needed extra help in. Study hall allowed the teacher to interact one-on-one with students who did not understand the content or may have been too shy to raise their hands in class. The teacher estimated that she worked with roughly 15% of the students in study hall. She also noticed that guided practice was a key to keeping students engaged. Guided practice allowed the teacher to highlight the code's logic by first explaining it in English, which also helped make the content more manageable. In addition, guided practice demystified coding because the students could see the teacher make intentional bugs as she was typing up her code, and then see the process she went through to debug her code. On the curricular side, framing the course around the Martian helped keep it fun and exciting. The teacher also found that the large variety of in-class activities were effective at allowing the course to engage with all students. For example, Libs was interesting for students who liked writing, whereas Turtle was interesting for students who enjoyed drawing. Finally, she felt that the robotics unit was important because it showed students a real-world impact of their code. It also allowed students who were behind to catch up without the students who were ahead getting bored, because there were numerous ways that students could go above and beyond the assigned classwork in the robotics unit. Finally, the robotics unit allowed students to get up and move around, which the teacher felt helped dissipate the students' energy and kept them more focused in class. At the beginning and end of every trimester, students filled out a pre and post survey that measured their attitudes towards computer science, such as confidence, interest, whether or not they would want to engage with computer science in the future, etc. All questions on this survey were measured on a 5-point Likert scale, and we had a 71% completion rate of the survey, or 180 students. We analyzed the results using a repeated measure ANOVA test, followed by a paired t-test for post hoc testing. Our within subjects factor was the time of the survey, and our between subjects factor was students' gender as well as their prior familiarity with Python. In the paper, we investigate 7 different constructs, of which I will highlight 2 in this presentation: confidence and students' views about computer science for the future. Our confidence questions were designed to measure how confident students were about their ability to learn and use computer science. This graph shows the pre-test results, where -2 is strongly disagree and 2 is strongly agree. In other words, the more negative the number, the less confident students are about their abilities in computer science, and the more positive the number, the more confident they are. This is the post-survey result, and as you can see, there is a notable shift towards the more positive side. And sure enough, this difference is significant. However, gender actually plays a role in this result. Amongst males, there was no significant difference between their confidence before and after taking the course, although amongst females, there was a significant increase in their confidence. Therefore, this course significantly lowered the gender gap in terms of students' confidence towards computer science. Our CS for Future questions, on the other hand, focused on students' willingness to take further classes in or pursue a career in computer science. Here are our pre- and post-survey results, and as you can see, the proportion of students who disagreed with the statements decreased. Sure enough, this difference was significant. However, in this result, prior familiarity with Python plays a role. Those students who already knew Python had no significant change in their willingness to engage with computer science in the future. But those students who did not have prior familiarity with Python significantly improved their willingness to re-engage with computer science. This shows that our course significantly lowered the prior familiarity gap in terms of students' willingness to engage with computer science in the future. Finally, we asked students about which parts of the course they enjoyed the most. As you can see, print and input, as well as conditionals, were the least popular components of the course, largely because both of them involved a lot of code on the command line. The teacher has taken this result into consideration, and in future courses has started incorporating the Finch robotics component earlier in the course, so students are not sitting and working with the command line for too long. Across both males and females, graphics and the Finch robot were extremely popular. Finally, as we had mentioned, one of the goals of this course was to provide students with baseline computer science knowledge that they could then use in high school. So how did the course actually affect high school course requests? Well, 2017 to 2018 was the first time the course was offered. And in the subsequent year, so this is the first group of 8th graders that had taken the mandatory course, the number of 9th grade requests for computer science courses roughly doubled, from 50 to 100. The following year, it increased by the same amount, to roughly 150. Therefore, since we began offering this mandatory computer science course, the number of 9th grade requests for computer science courses has roughly tripled at our school district. However, one thing to note is that the gender ratio has stayed roughly the same, at 2 boys for every 1 girl. So this course clearly needs to go farther to encourage girls to engage with computer science. Note that this effect actually persists beyond 9th grade. This graph shows high school computer science course requests across all grade levels. The 9th grade data is what we had already seen, going from 50 to 150 over 2 years. However, if we look at 10th grade requests, they also increased from 62 for the 10th graders who did not take the 8th grade course to 101 for 10th graders who did take the 8th grade course. Therefore, the impacts of this 8th grade course carry on at least 2 years since the students take this course, and we're excited to see how this trend might pan out in future years of high school. In conclusion, we developed and taught a mandatory one-trimester Python course for 8th grade students. The curriculum was intended to balance core computer science skills with fun activities, such as making Mad Libs and using the Finch robot. Teaching to all students presented unique challenges for the teacher, and she required on a study hall as well as a variety of activities in the curriculum to engage all her students. And finally, the course significantly improved students' attitudes towards computer science as well as their high school computer science course requests. I'd like to end by acknowledging my co-authors, the institutions that supported this work, and most importantly, Lynette Lortz, who taught the course. Thank you for listening, and we are available to answer any questions over email.